Hello everyone, I'm Paul and today we're solving problem 2616, minimize the maximum difference of pairs. This is medium and this might be tricky if you have never seen something like this. So here I will show you how to solve this step by step. We're given an integer array nums and an integer p. And our job is to find p pairs of numbers such that the maximum difference among those numbers is minimized. And the difference needs to be absolute. And what this means is we can sort the numbers. So this is key here. And finally, we need to return the minimum maximum difference among all p pairs. Now, this might be confusing. Here we need to find maximum differences and then minimize that. So we'll go through each part of the logic. And the key to solve this is binary search. So here I will show you an example and how can we solve this step by step. Let's say we get these nums and p equals 2. Our strategy here will be first, find the maximum difference, and second, find the minimum difference for p. In this case, p equals 2. Let's see what this means. Let's start with the first part. How can we find the maximum difference here? Well, we know that the maximum difference is 10, which is the maximum element here, minus the minimum element, which is 1. So the maximum difference is 9. And now we know that the result goes from 0 to 9. So we can run a binary search here, starting from the midpoint, and we can check if we have enough pairs, meaning 2 or more pairs, with a difference that's smaller or equal to 4. And if we have enough pairs, we move the right pointer to the left, and if we don't have enough pairs, we move the left pointer to the right. Let's see how can we do this step by step. First, remember we are trying to find the maximum difference here, and we also need to run a binary search. And to run a binary search, we need to have a sorted array. So the step 1 here is to sort this. And now we can find the maximum difference by taking the last element in the sorted array and subtracting the first element. So 10 minus 1 is 9. And we will use 9 as the high bound for our binary search. So our binary search will go from 0 in the low bound to 9. So now we can run this binary search and we start from mid and we need to round down this value. So mid would be here, we round down the value, now we're here. And this is 4. And now we'll check how many pairs can we find here with a difference of 4 or less. So we will iterate this from left to right from index 0, and we'll have a variable here. We'll call this count, and this is initially 0. And here we will keep track of all the valid pairs for this limit. So we start with the I pointer here, and now we are comparing 1 and 1. The difference is 0, and 0 is smaller than our limit, which is 4. So we add 1 to the count. And now we know this is a valid pair and we can't repeat indices in valid pairs. So we need to update I 2 steps. Now I is here and we are comparing 2 and 3. The difference is 1. And 1 is also smaller than our limit, which is 4. So we add 1 to the count. This is now 2. And here we found another valid pair, so we update I 2 more steps. Now I is here and the difference between 7 and 10 is 3, and 3 is smaller than 4, so we add 1 to the count. This is now 3, and we will end this loop at n minus 2, meaning here. So now our count is 3, and this means that we have 3 valid pairs in this array when the maximum difference, when the limit is 4, and 3 is greater than 2. So now we have 3 valid pairs for this limit, but the problem requires to find the minimum maximum difference. So we can try a minimum limit here. We can move this mid pointer to the left. And the way to move this to the left is by moving the right pointer or the high pointer to the mid pointer. So now the high pointer is here at 4, low pointer is at 0, and mid pointer is at 2. So now we'll do the same process with 2 as the limit. We'll iterate this from left to right, starting from index 0 up to index n minus 2. And we will have a variable to keep track of valid pairs. We will call this count. This is initially 0. And first we have 1 and 1. The difference between 1 and 1 is 0. And 0 is smaller than our limit, which is 2. So we add 1 to the count and we update I 2 steps. Now I is here and we are comparing 2 and 3. The difference is 1 and 1 is smaller than our limit. So we add 1 to the count. This is now 2 and we update I 2 steps. Now we are comparing 7 and 10. The difference is 3. And 3 is greater than our limit, so we keep 2 in the count. And now we end this loop here, and 2 equals p. So what this means is we have 2 valid pairs here for when the maximum difference is 2. And this is valid, but we can try to reduce this limit a little bit more because we are trying to find the minimum maximum difference. So now the high pointer is at 2, the low pointer is still at 0, and the mid pointer is here at 1. So we are doing this same process with 1 as the limit. So we do the same here. Initially the count is 0, the high pointer is here at index 0, and we are comparing 1 and 1. The difference here is 0. 0 is smaller than our current limit, which is 1, so we add 1 to the count and we update I 2 steps. Now I is here and we are comparing 2 and 3. The difference here is 1 and 1 equals our limit, so we add 1 to the count. This is now 2. We update I 2 steps. Now we are comparing 7 and 10. The difference is 3. 3 is greater than 1, so we keep 2 in our count. And 2 is still equal to p, so we can try and reduce this limit a little bit more. Now the high pointer is here at 1 and low and mid pointers are here at 0. So now the limit is 0 and we are doing the same process. First we compare 1 and 1, the difference is 0. 0 equals to our limit, so we add 1 to the count. We update I 2 steps. Now we have 2 and 3. The difference here is 1. 1 is greater than 0. So we are not updating C. And instead of moving I 2 steps, we are moving I only 1 step. Why? Well, because this is not a valid pair. But this might be a valid pair, so we need to check this. That's why instead of moving I 2 steps, we're moving I 1 step only in this case. Now I is here and the difference between 3 and 7 is 4. 4 is greater than our limit, which is 0, so we update I 1 step. Now we're comparing 7 and 10, the difference is 3 and 3 is greater than 0, so we update I and we reach the end. Now the count is 1 and 1 is smaller than p. So what this means is when the limit is 0, we have only 1 valid pair here, but we need at least 2. So in this case we need to move the limit to the right. And the way to do this in binary search is by updating the left pointer. So now the left pointer is at mid plus 1, meaning here, and now left equals high. So we end the binary search here and we return the result, which is 1. And what this means is the minimum maximum difference among two pairs when we have this array is 1. And more specifically, the chosen pairs here are this and this. The difference here is 0 and the difference here is 1. The maximum difference between these two is 1. And this is the minimum maximum difference that we found here. Time complexity for this will be big O of n log m, where n is the size of this array and m is the maximum difference, because binary search has a logarithmic time complexity. And space complexity will be big O of n in Python because we are sorting this. So now let's go with the code and hopefully you will get the idea. First, n equals the length of the array nums, and we need to sort this array, so nums.sort. And now we'll create our function to get the pairs for every limit in our binary search. So we'll call this pairs, and this will take some limit, we'll call this x, and I is initially 0, count is initially 0, and now while I is smaller than n minus 1, remember that we are iterating this up to n minus 2. So while I is smaller than n minus 1, if nums at I plus 1 minus nums at I is smaller or equal to x, I plus equal 1, count plus equal 1, and here we need to update I with plus equal 1. Finally, we return the count. So now we have this function and we can continue with the binary search. Here the low pointer is initially 0, high is initially the maximum difference in this array, so nums at minus 1 minus nums at 0. And now while left or low is smaller than high, the mid pointer will be low plus high minus low divided by 2. Remember, we need to round down this value. And if our function pairs at mid, this is mid, is greater or equal to p, high equals mid, else low equals mid plus 1. And finally we return low. So this is it for the code, and now let's submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.